Hello everyone. Today we are going to go through the advanced probability, and I highly recommend that if you've not watched the basic probability video, the part 1, that is the first thing you should watch, and then you should come to this video because this video is very much linked to the previous one. Now let's dive into the topic. Okay. So we start with set notation because obviously in the previous video, we've discussed what is probability, what are outcomes, what are experiments, what are events. We discussed and, or, and not cases. And I told you over there that the and is basically intersection and or case is union. We're going to see this with the set notations, right? So you need to know a little basic about the sets topic. And a set notation is basically you're using a formal way of writing groups of numbers, right? Or maybe there can be other mathematical entities, even shapes or, other things. Now, if a certain numbers or certain group of elements that belong to one set, they share a common feature, right? And each member in the set that is known as the element, right? Set of natural numbers, they're denoted by this n. Set of real numbers is denoted by r. Now, in probability, set notation is important. And how it is important, we can talk about the sample space and events, right, with the help of set notations. Now, all these symbols, SU, and these two fancy E's, there are the common symbols for the universal set, and that in the case of a Venn diagram is represented through a rectangle, right? So this is your universal set, right? And in which let's consider there's a set A. Right? It's a part of the universal set. Because in universal set, everything is included. So yes, definitely it is a part of the universal set. Now, in events, they're denoted by the capital letters, A, B, C. Right? And the event not A, not B, not C, that is known as the complement. And we've discussed in the previous video. If let's say the universal set represents numbers 1 till 5. A represents even numbers, so it will be 2 and 4. And so not A is basically A complement, which will represent numbers 1, 3, and 5. Numbers which are not even. Okay? So, yeah, this is about it. Now, in probability, we are actually looking at combined events, right? We want to look at two events. Now, an event, the event A and B, if we want to know, and we are actually looking at the intersection of A and B. We want to see all the outcomes which are a part of event A as well as a part of event B. So on the Venn diagram, that would be the overlapping part, right? You can see over here. This represents intersection, right? This is one. And here the overlapping part has been shaded because that is, it will contain all those elements which are a part of A and B. In other words, it will contain all those outcomes which happen and cause event A and event B both, right? Now, then there is union. Union, there's a symbol of U, you're uniting everything, you're unifying. And this would be both the bubble for event A, the bubble for event B. This is for mutually exclusive events, right? They overlap, they include the intersection as well as the individual ones, right? So probability of A union B will be probability of A plus probability of B. You can see over here, this first figure is for the union. And then a complement. Complement is simple. We discussed it in the last video as well, right? Complement is simply 1 minus probability of A. So probability of A complement will be 1 minus probability of A. That means you have to leave out everything except the, you have to leave out A and you have to include everything except A, right? So A complement, not A, right? So everything is shaded except for A, right? Now, how to solve such problems? Because obviously we're doing this from an exam point of view. We need to understand how to solve problems, right? Now, it's very important to, you recognize all the notations and symbols. Then you can interpret them. We have interpreted this as and, this as or, this is your not statement, right? You know how to calculate 1 minus, okay? So Venn diagrams, they show you good picture of it, right? So it's always good when you have set notations, you should draw Venn diagrams, right? Because they help you to shade and give you a visual representation, right? So there are three things we have understood: union, intersection, and complement. Now they can be more than one way of writing. Now A union B complement. Now what is this actually? If I make the Venn diagram for this, so this is A, this is B, A, B. Now this is A union B and complementing them. That means everything except A union. Now A union B is this part, so everything except A union B is simply finally all the things outside. Right? A union B, everything except A, the whole of A and the whole of B. Now this can also be written as, if I write it as A complement intersection B complement. Now what is A complement? A complement is everything except A, even this part. But what is B complement? Even this part is included, but and the whole background part. But when you intersect both of them, since this is not common for both A complement and B complement, this part is gone. Only the background part is left. Similarly, for A intersection B complement, we can draw A, B, A intersection B. Intersection is only this part. Let's say this is A, this is B. Intersection is only this part. So if you want to do intersection, complement, so everything except the middle part shaded. Right? Everything else will be shaded. Okay? Except for the middle part. You can also write this as A complement union B complement. Right? Because, see, what is A complement? A complement is this part, right? And what is B complement? B complement is this part. All of it united. The same things are shaded, right? So, right, you can get shading related questions. So I hope the shading concept is actually clear to you, right? You can even watch our videos on sets topic, right? So that would, give you a broader understanding on shading and everything. Okay, so let's move further. All right, we have a question here. Write the following probability statements in Word. Now, this is the probability that A has happened and B has happened. This is intersection. Probability of A union B will be the probability that A has happened or B has happened. Right? This is or. This is A complement intersection B. The probability that A has not happened and B has not happened. Right? Both of the events complement, that means not. And this is A union B complement. Right? So this would be the probability that neither A has happened nor B has happened. Right? And if you want to make Venn diagrams, we've just discussed about Venn diagrams. You can try that question on your own and you can check your answers from here. Okay. Now we will move towards the next topic, and the next topic is conditional probability. Now, conditional probability is where the probability of event happening can basically depend on the outcome of a prior event, right? Let's say you have been, let's discuss an example, okay? For instance, you have a bag, and in that bag, you have, let's say, green and yellow balls, right? Let's say you have 3 yellow balls, you have 2 green balls. Now, if I tell you that you need to find the probability of 1 yellow ball, you'll be like, it's simple. 3 yellow balls, 2 green balls. I think that's what I said. If that's what I said, then it will be 3 upon 5. If I take out a yellow ball, now I've given you the condition of an event that given that 1 yellow ball has been taken out, now you will say now the probability is 1 upon 2. So the probability depends on a previous event, right? Drawing more than 1 counter bead from a bag without replacement, you're not replacing them, then yes, it is conditional. We have also discussed a similar example. You're not replacing the ball, right? So this is one of the examples. Because your probability has now changed, it was 3 upon 5, now it is 2 upon 4, right? The probability has changed depending on your first event, right? Now you can see bag with 6 white and 3 red buttons. One is drawn at random, not replaced. Second button is drawn. Probability that the second button is white, given that the first button is white. So now you're gone with 1 white button. You are left with 8 buttons and 5 white buttons. So the probability will be 5 upon 8, right? Now the key phrase over here is this. It is given that. Given that means that something is already happened. If this is written in your paper, you need to understand that they're talking about conditional probability. And if it's not written, it will be indicated by this vertical line. This is the notation for conditional probability, or it is the notation for given that. So if it is written second is white, you will translate this line as given that first is white. So the probability is 5 upon 8. Okay. Now, in this case, again, Venn diagrams can be helpful, right? Now, but in this case, the denominator of the fractional probability is not the total of all frequencies, right? We will see how the denominator changes. Now, look at that. If you have probability of an event B, given that A has happened, so the actual probability, how do you find? Sorry. The actual probability, how do you find? You find it through probability of A intersection B upon probability of A. Now, I'll explain you why. Why is that so? Now, A has happened. We already know. So, this whole blue part, the blue and the purple part, it has already happened. Out of it, we need to know that what is the probability that B will also happen. Now, that means since A has already happened, B happening means that the only chance of B happening is in this purple part. It cannot be over here because you know that A has already happened. So either it can be B intersection A or only A, right? So that is why your numerator part, now your favorable outcome is not the whole B. It is just A intersection B because A has already happened. Alone B cannot happen. And the total probability is probability of A. Because now you do not need to filter it out from this whole Venn diagram. Only A, because A has happened. Similar is the second diagram. Probability of an event A happening given that B has already happened. I won't go into the details. You can relate it. Probability of A intersection B upon probability of B. Right? Now, okay. Right? So you can even write it this way. Probability of A intersection B is equal to probability of A into probability of B, given that A has happened. Now you can manipulate the formula. Now for independent events, you know that probability of A intersection B will be probability of A into probability of B. Now, for those who do not know, we have talked about this in the previous video, but for those who do not know, what are your independent events? Let me draw a Venn diagram and explain it, right? About your independent events. Right? Basically, probability of independent events, probability which do not depend on each other. So, probability A, B. This intersection part will be probability of A into probability of B. Now, probability of B given that A, probability of A into B, probability of B, right? Upon the probability of A. That gives you probability of B. Now, what does that mean? These events are not depending on each other. Obviously, if they're not depending on each other, then the definition of conditional probability is given that after the event after given that has to be dependent on the previous event. Probability of B given that A, that means B has to depend on A at some point, right? Since it's not, that means probability of B stands independently and it would remain the same. Right? If events A and B are independent, then the fact that event B has already occurred, it won't have any effect on the probability of event A happening. Right? Now we will discuss the next topic, that is two-way tables. Right? In probability, two-way tables are very, frequently used. You can see this AB represents probability of A intersection B. A complement B, A complement intersection B. And A or in these in same way, B and B complement, A and A complement, they cover all the part that is equal to 1, probability of 1, that is your universal set. Probability of having a universal set, obviously, your total outcome is upon total, that is 1. Right? Now, here you can see overall A. How do you get overall A? A intersection B complement plus A intersection B, right? So you should, try sketching for all of them. That would, help you in shading, and that will help you in the topic we are now, starting. We're now working with. Okay. Now, how do you solve the two-way tables, right? Questions won't mention two-way tables most of the time. That is, you need to identify, do you really need the two-way table here? The question talks about, it has to be interpreted in the form of and or not given that, right? Sometimes the question might not be that strict, right? But always, I suggest you that you should go with the table, complete the table with as much as information you have. Then you can, always fill out the missing values through the row. This is how you will complete the whole table we've discussed, right? You can then complete the missing out rows, right? That you will be able to do. Okay. So also remember that union is actually the middle part is for in union. You do not have to include it twice. If you do probability basically P union Q as probability of U and probability of Q, that's not right, right? Because then the intersection part will be added twice. So you need to, subtract the intersection part. Remember all these things, and you will be able to solve the questions in a good way. So we're done with the topic here. Thank you so much for hearing this video out.